Okay, our last video of section 3.1. We're going to talk about complementary events, and then we're going to kind of tie everything together. So let's start with complementary events. The complement of event E, is the set of all outcomes in a sample space that are not in E. So what this looks like is if I were to draw just some set sample space, maybe I'll do something like this. If E were the circle in here, okay, so if E were the circle, then E complement would be everything out here. So we would mark that with an E and then an apostrophe. Sometimes you might see a C right there. Our book uses an apostrophe. But if I think of this whole rectangle as being my sample space, S, then that means the probability that S occurs is equal to the probability that E occurs plus the probability that E doesn't occur, which equals 1. E will either occur or it won't. So if I add those together, it should give me a probability of 1. Now, what I can do with this is I can figure out, well, what's the probability that, E doesn't occur? So I can easily say the probability that E doesn't occur is just 1 minus the probability that E does occur. If E has a 40% chance of happening, then it has a 60% chance of not happening. We deal with complementary events, I almost want to say every day. I mean, if you look at the weather, and the weather's saying, oh, there's a 20% chance of rain today. How many times have you said, well, there's an 80% chance it doesn't rain today? That's a complement. So you can also flip it around. I could say the probability that E does occur is 1 minus the probability that E does not occur. So there's different things we could get from this. So let's look at an example. This is example number 8. I want us to use the pie chart from example number 6 to find the probability that the next person interviewed did not read only digital books. Okay, so what I'm going to do is I'm going to come up here and I'm actually going to just paste in a picture of the pie chart. So let me go grab that right quick. Okay. Here. Insert screen clip. No, quite. Okay. So remember that from this example, there were 1,490 total. Okay, so we want the probability that they did not read only digital books. Well, it says that 91 read only digital books. So probability that they did not read, so not only digital. That would just be 1 minus the probability that they read only digital. So 1 minus the probability, oh, I don't even need probability. I can plug numbers in now. 1 minus 91 over 1490. Which would give us, to 3 decimal places, 0.939. So that's our probability that the next person interviewed did not read only digital books. 0.939, or almost 94%. That's a compliment. That's a compliment. Okay. And our last example. We made it to the end. Yay! Example number 9. Insert screen clip. Probability experiment consists of tossing a coin and spinning the spinner at the right. Oh, wait, hang on. Tossing a coin, spinning the spinner, and rolling a 6-sided die. So we're doing 3 things. Find the probability of tossing a tail, spinning an odd number, and rolling a 3. They're asking a lot here. Okay. So we can use the fundamental counting principle here. Let's first figure out the total number of ways. So total number of ways. Okay, well, what do we have to do? We have to toss a coin. So the coin, there's 2 ways. We have to spin the spinner. How many numbers can you land on the spinner? 5. And then we have to roll a die. 6 ways. So the total number of ways would be 2 times 5 times 6, which is 60 ways total. Okay. Our next task is to figure out what I call the desired number of ways. Desired number of ways. Well, what do we want? We want a tail. Well, that's just one way. We want an odd number on the spinner. So odd spinner. Well, that'd be a 1, a 3, and a 5. So those would be our odd numbers. If I look up here at the spinner, a 1, a 3, and then a 5. That's 3 ways there. And then the die, I want to roll a 3. That's one way. So 1 times 3 times 1 gives us 3 desired ways. And then the final step here is to get our probability. Probability, that would equal 3 over 60, which reduces to 1 over 20. Or if you wanted to put it as a decimal, you could say 0.05, or you could put it as a percent, that's 5%. You're like, my goodness, enough. I get it. That's the different ways you could write probabilities. You could write them as a fraction, a decimal, and a percent. Now, something to note, we don't really need to know this right now, but anything, so probabilities less than or equal to 5% are actually considered unusual. So, having this exactly happen like we want, we flip a tail, we get an odd on the spinner, and we roll a 3, that's going to be unusual because it's less than or equal to 5%. Okay, so that is the end of section 3.1 over basic concepts of probability and counting. In the meantime, we're going to do 3.2 later, but in the meantime, remember, you are loved, you are created to do wonderful things, and you are awesome. Always believe.